computer. All right, the screen is sharing. We are recording. The mic's working. All right. So the video from morning is uploaded. It's being processed right now. So it should be up probably within the next hour. We finished invariance, sort of, mostly. I don't know if we understood it, but we finished it. Again, word on invariance, we went all the way. Like, we went super deep into invariance. You don't need to do that for most of your papers you write up. If you're doing multi-group analysis, you need to do a configural invariance, maybe a metric, scalar if you're publishing to maybe a rigorous marketing journal. But otherwise, you're probably good just with configural. Okay. Method bias.
So,
yeah.
You're going to touch on Chisquare.
Oh, the Chisquare difference test. Yeah. So let me show you one thing real quick. With in fact, we could talk about that with a method bias if we want to do it with that one. We're going to do the same in there. All right. So there was a question locally to do Chisquare difference test and explain it. We'll do that with method bias. So method bias. What is method bias? That's probably not the best. We should call it specific bias or common bias. Remember that slide where we had the 3 different types of variance that are captured whenever you measure anything? One of those was method variance. And that is variance that you can't really control very well. It's variance due to the way a respondent reacts to your measures. Like if you're asking about bribery, they might say, oh, no, even if they do bribe, they might say, oh, I don't bribe. And so there's the value they report isn't the true value. And so there's specific kinds of biases. There's social desirability bias. That would be like bribery. There's a socially desirable way to answer that question. There are biases that are more prone to what's called endogeneity. Endogeneity is when there's some third variable making everything related. So like if you ask someone, some employee, if they think their company is innovative, if they think their company is cutting edge, if they think their company is going places, things like that. And you also ask about the performance of the company. Do you think the company's performing better than competitors and all that stuff? Those two might be related, but it might be because there's some third variable like loyalty to company that is raising both of those up. And it's not really a causal relationship between innovativeness and firm performance. It's a relationship from attitude towards the company to both of those. And so this is another type of bias. You could have a pessimism bias. Some people are just down about everything, right? Everything's bad. Or you get an optimism bias where they're just happy about everything. All of these things affect the way people respond to surveys. And so we need to control or account for that method bias. It's even better if you can just prevent it. One way to prevent method bias is to make sure that your dependent variable isn't a perceptual variable. You can make your dependent variable an objective variable, like revenue. There's no bias in revenue. You can buy it. It's an objective number that is reported. It is not swayed by the way you feel that day, for the most part. Things like that. Any outcome variable, any dependent variable that is objectively measured, not perceptually given, would prevent the issue of method bias. Or if you collect your dependent variables separate from your independent variables, so like in a different survey, then that would prevent method bias because it would be different day, different time, different situation, different feelings, different moods. Yeah. The problem with objective measures, though, as a dependent variable is it's hard to predict them. So whereas with perceptual measures, you have a pretty high R-square. With objective measures, typically it's a fairly low R-square. But assuming we didn't prevent method bias, we need to account for it so that we don't accidentally have a false positive where we think things are related, but really it's due to something else. And so the way to do that, multiple ways to do that, and we have some here, but I'm just going to show you. In Amos, where did Amos go? There it is. In Amos, let's go back to our initial CFA. Let's see, file, CFA initial. Just a nice clean one. Here's our nice clean CFA with social desirability in there. Social desirability is a specific bias variable. It is what we think might be affecting the way people answer our questions about being innovative and playful. There's a right way to answer those, right? Of course you're an innovative person, you're a playful person. Of course you don't have anxiety when it comes to using computers. At least you're less likely, or you're more hesitant to answer in the socially undesirable way to answer those. So we're gonna account for that. Someone's mic is on. Let's see. It's Chris's. I'm gonna mute you, Chris. There we go. Okay. So the way you can account for it is by actually measuring social desirability. If you were worried that it was optimism, you'd want to measure optimism. If you were worried it was attitude towards the company, measure attitude towards the company. And that becomes your specific bias variable. If you've already collected data and you don't have a specific bias variable, there's a way to deal with that too. I'll show you that in a moment. But let's assume you have a specific bias variable like social desirability. Let's do this. Let's move this whole model. Let's see. Select all, open hand. That turns everything blue. Truck. Fire truck moves stuff, obviously. Let's move it to the right. Just so we have some room. There we go. And then deselect all, that's with the closed hand. And then we're going to stick in a common latent factor. This is a factor that is common to all observed, all measured items. We can just make a nice big factor here. That's with this big ellipse.
We constrain it too.
Yeah, we're gonna do a few things to it. First, we're gonna unclick it. There we go, so nothing selected, you just have your pointer. Double click it. Let's constrain its variance to 1. That's in the parameters tab. And in the text, let's give it a name. Let's call it CLF. Common latent factor, CLF. There we go. And then what we need to do conceptually is yes? Was that, yes?
No, sorry.
Okay. I'm gonna mute you. There we go. Okay. Here we go. Conceptually, what we need to do is we need to account for the variance that is shared amongst all variables, including social desirability. And the way we do that is we draw a line from this latent factor to every observed item, which is a pain in the rear. But you could do it, like click on the single-headed arrow, click and drag, click and drag. We had to do this 47 times, but I'm not gonna do it 47 times because that's ridiculous. I'm gonna close that or delete those two.
Sounds like time for a plug-in.
It's time for a plug-in, folks. Who is following along step by step? You are? Okay, need to get the plug-in for this then. So the plug-in is over here in that folder, that Google Drive folder, and it's called CLF. So you just want to, again, download that file.
I have one called Common Latent Factor Connector.
Oh, that's a different one. Or, well, that might, yeah, use the CLF. Oh, you have to go get it. Okay, so download it, unblock it, stick it in the right folder. Yeah, this will take a moment.
So if I already had it, okay.
If you already had it,
Under my plugins.
in plugins, if you already have it, it would look like this. It would look like specific bias test.
Yes, we
Yeah.
have that specific bias test.
Yeah, okay. I also have a common latent factor connector. That's a different one. Yeah.
Specific bias test. Yes. All right, are we running that?
Not yet.
Not yet.
Yeah, but you could, but not yet.
No, I wait.
Okay, so get that plug in, download it, unblock it, stick it in the right folder. Remember the right folder is way deep. It's this place. If anyone's having trouble, I can come around and help them out.
He just threw down the gauntlet.
I want to see if it works. I haven't used this thing in months.
I haven't had good success recently.
Uh-oh. Okay. If it doesn't work, we'll do the old-fashioned way.
I've done it both ways, and each way
It breaks.
there was a different answer.
Ah, that's not good.
No.
Okay.
Can I read you your conclusion from my previous run of it, or not right now?
Let's get to it in a moment. Yeah. How's it coming getting that plug in? We good? Not good. Oh, okay. Just let me know. Oh, okay. You sure? Okay. Okay. So back in Amos, what you want to do with the plugin is you'll want to, single finger click and then select the CLF so it turns blue. It turns red when your mouse is over it, but then move away and it turns blue. And if it didn't, click on it again with the single finger clicker. Oh, that's hard to say. Single finger clicker. All right. Okay. And then you go to plugins and specific bias test. Please work. And it's going to say it's going to run many times, and just hit proceed when it asks you to. So you hit OK. Proceed.
My CLF just stays red for some reason.
Proceed. Oh, it just disappeared.
Mine didn't work either. I'm gonna add that other factor.
It like disappeared. Here's my model. Where'd it go? There it is. Is it still running? Ah. I don't think it's still running. Did that work? No. It's supposed to work. Oh, well, poop.
Mine said solution could not be generated. Try running the model with model bias plugin to troubleshoot.
Mine has some, oh, here it is down here. It's still waiting to run. There you go, proceed.
Yeah, I have that too.
So it's still running with mine. I just had a hidden window. Hey, it ran.
Okay.
If yours didn't, we'll figure it out, but it ran. So what just happened? What just happened is we ran, let me zoom in here. We ran multiple chi-square difference tests. A chi-square difference test is where you take the chi-square in degrees of freedom of one model, you compare it to the chi-square in degrees of freedom of another model, and then you check the difference. And if the difference is significant, then the models are different. And in this case, we used the unconstrained model as the base model, and that's just this model, well, with the CLF connected. I don't know why it disconnected them. We used the CLF connected model as the base model, and then we constrained all the paths from the CLF to the items to be 0, which means there is no common shared variance, or it's no different from 0. And so we compare that to the one where it says, no, there is something different from 0. And it says, here's the difference in degrees of freedom in chi-square. And if you run that in a chi-square difference test, you'll get a p-value that is significant, meaning these are different models, meaning there is more than 0 bias present. And then you can run it again to see if that's equally distributed bias. And the answer is no, it's not even equally distributed. It's lopsided bias. Conclusion is that there was measurable bias detected, unfortunately. And so it's unevenly distributed. And so you should retain the constructs, the common latent factor and the specific bias constructs as you impute factor scores, which we haven't done yet. But as you move on to a causal model, you want to keep those factors in to account for the bias. Let's do it more manually. Okay, first off, one of you has a factor that's red like mine, and you can't even do anything with it. It's just red. Even if you hit deselect all, it's still red. So what you do is you close the model and reopen it. So I'm gonna go File, I'll save as CFA, CMB. No! Already exists. Replace it? Yeah, sure. And then I'm going to reopen this file. And it's not read anymore if you reopen it. I'm looking at structural equation modeling blue book for an overview of SEM. Do you suggest some other text? I don't like SEM books. They're all terrible. That's why I made the videos. I don't know of any good SEM books. Sorry. But that is why I made all the videos. I don't know what that says about me. But yeah, I don't like the books. Okay. SEM is a very visual thing. It should be done visually in videos, I think. So to do this more manually, let's say the plugin didn't work. Does your connector plugin work? Like that connects all the arrows? We could use.
Mine worked that time,
Oh, yeah, yours worked.
but I don't know if it's going to get the same answer as the manual.
So let's do it manually. What you have to do manually is connect. Well,
let's try the connector.
let's try the connector. So
CLF connector, right?
CLF connector, right? Highlight this, plugins, common latent factor connector. Please work. Oh, yes.
Yes.
Yours didn't work? Can I undo that? Whoa. I'm just going to delete it. So I'm remembering how the CLF works. If you name the factor, then it constrains all paths to 0. If you don't name the factor, it does an unconstrained test. So what I would do in plugins, I would have an unnamed latent factor here.
Oh, you didn't name it all?
Yeah, for the first pass, I would leave it unnamed.
Oh, I didn't.
That's all right. So just delete it and try again. And then what it does is it leaves it unconstrained. So you can run an unconstrained model.
Okay. So you just made,
Yeah.
and then you ran that.
And we can run this model to get the chi-square and degrees of freedom. Again, it's all unconstrained
It automatically constrained it whenever I ran that.
to 0. Oh, the 1 is fine.
Oh.
Yeah, the 1 is fine. So my CLF is constrained to 1, the variance.
Yeah, just do the circle. And then run high, plug it the same. And then plug in latent factor connector. Don't do that, do the other.
Remote folks, you probably can't hear. We're just running through a few troubleshooting issues here. So we're just doing this again manually.
And then do the specific bias test?
Now we're caught up.
No, so if you have an unnamed latent factor here, and it's highlighted, use the connector, the common latent factor connector. And it should look like this. We run this to get the chi-square and degrees of freedom, which is in the output, which is hiding. There it is.
So just connect it and run.
Just connect it and run it. So there are no constraints on those paths. And what we get when I run this one is I get a chi-square and degrees of freedom of 1413 and 789, which I'm going to go put into Excel.
So
Chi-square and what was the other thing?
Chi-square and degrees of freedom?
is that just the result of the unconstrained?
Yeah, just the unconstrained chi-square and degrees of freedom. In fact, I'll just make a little table here. Chi-square, df, and then diff. And we'll have unconstrained and constrained.
Oh, so we can just use your spreadsheet.
Or you can just use the spreadsheet I've already made. But this is how you would do it. This is what's going on. Is the chi-square here was 1413.222, 1413.222, and the degrees of freedom was 789. And then what we do is we run the model fully constrained. And the way to do that is while the CLF is named and we already have it up here, go to the CLF connector again. Oh, select the CLF. And select the CLF connector again. And then it constrains them all to 0, hypothetically speaking. Now you're good. I'm just going to delete the CLF and reinsert it and name it. Whoop. If you name the CLF when it's in there, then it constrains them all to 0. And if you're like, man, I'm never going to remember all these steps, there's a video for it. Highlight the CLF when it's named, and then do the latent factor connector.
Oh,
And then it's constrained to 0,
I understand.
meaning no bias different from 0.
It really is just a matter of the order of operation.
Yeah, and there's a video for it.
Oh, my first.
So the difference that you're doing is between.
Unconstrained and fully constrained to 0. That's what I'm looking at the difference.
Chi-square and then the degrees of freedom, and then you had difference. What was the difference in the Excel spreadsheet you did?
Oh, I haven't put it in there yet.
That was just his.
So I can run this. Yep, proceed.
Oh, my goodness.
And it'll give me a new chi-square in degrees of freedom for the fully constrained to 0 model. 1541.061 or 016, 1541. 1541.016. And degrees of freedom of 832.
Yeah. And
And then you just look at the difference.
And you name it.
This minus this, oops, equals this minus this, and equals this minus this. So there's a difference between chi-square and degree of freedom between the two models. And then you run what's called a chi-square right test, equals chi-square right-tailed. Oops, it disappeared. Chi-square. This one, .rt. What this will do is it'll produce a p-value for the difference between those two models. And I'm using the right-tailed because it's a little softer solution. It's a little more forgiving. It's just one-sided.
I think
Where the chi-square, the x, is the difference in chi-square. And the df is the difference in degrees of freedom. And the answer is,
my work.
that is a really small number. If I were to turn this into a number, it is 0. Meaning these two models are very different, meaning that we can't be confident that the bias is not different from 0. So the bias is different from 0, therefore there is bias. Do you need to see that formula? Is that what you're looking for?
I think so X is the chi-square difference.
Yep.
And then degrees of freedom is the degrees of freedom difference.
Correct.
And as long as you do them in the same direction, you're good.
Yeah, essentially, yeah.
Okay.
Cool.
All right. And the interpretation.
So if you get a p-value less than 0.05, then there is bias.
So we keep
It's
it.
greater than there's not.
And if it's greater than 0.05, there's not bias. If you determine that you do have bias, then what you need to do next is unconstrain all these from 0, because they can't be forced to be equal to 0, because that was the wrong model apparently. So the easiest way to do that is literally just delete this factor again and put a new one in. And highlight it and use the CLF plugin to connect them. So now we're back to the unconstrained model. And what we need to do is check our validities of the factors we care about with this model.
So how does, whenever we ran the bias plugin, it gives you the output for equal,
Yeah.
but
So
you can't do that with the connector.
you can also create equal constraints, but you have to do it manually. You have to name all of those paths the same thing or set them equal in a model, a constraint parameter or dialog. So it'd be a pain in the rear. Most people don't care about equal constraints because there's nothing you can do about it. It's just like, oh, okay, it's not equal.
I think
Nothing you can do about it. So I don't even run it. We just want to know if there is bias. And it turns out there is. So since there's bias, we need to account for that bias. What we need to do now is see if this broke our model. Because often the CLF will break your model and it just won't work properly. So let's run this. Proceed. Wait for it to run. It's a lot more complex now. hit the up arrow, and let's see if there's anything that's super broke. Be easier to do it. Oops. Ah. This way. So useful still looks mostly good. Anxiety looks good. Playful looks. I'm just looking at the factor loadings, the indicator loadings here, making sure they're still upwards near 6, 7, somewhere around there. Oops. And let's see. Decision quality, it's affected quite a bit, but it's not too low. Ooh, information acquisition is broken. You can see we have like a 101 and a 0.02. That's a problem. All right, and so is, and then these ones we don't care about down here. But information acquisition is broken. So what do we do about that? Dang. What we can do is hit that down arrow and fiddle. This is a weird aspect of Amos. You can fiddle with the constraint and it'll change how bias is extracted. So instead of having the constraint on the first one, let's just move it. So delete that one and let's put it on the second one. Or actually, you know what, let's put it back out here on the, yeah, stick it on the factor. Give that a variance. So all we did was move the factor constraint. See if running this fixes those weird loadings. And up arrow. Ah, it fixed it. Cool. Now that it's fixed, call me crazy, but I want to run my method bias test again. Yeah, I'm crazy. I know. It's okay.
Go crazy.
Go crazy. So here are my chi-square and degrees of freedom. We already have them. So this is the unconstrained model, 1372-914. 1372-914. 1372.914. And the degrees of freedom are 789. That shouldn't have changed. Yeah, 789. And now I'm going to run the constrained model. Plugins. Let me down arrow this. Plugins. Connector. Oh, I must select the CLF. The reason I want to run it again is because the last model was run on a broken, or the last time we ran it was on a broken model. So the estimates it gave us aren't valid. Did it just run? Nope. Hello? Select. There we go. Plugins. Connector. Man, it really doesn't want to do that. Fine. Deleted. Try again. Buggy, but it's still faster than doing it manually. Selected, plugins, connector. Yay, it worked. Okay, now we run it. Get the new fully constrained to 0. And the chi-square degrees of freedom are 1541.016, 1541.016, and probably 832. And 832, yep, and it's still a problem. Yep, it's still a bias. So, but the model works this time. So
if that's, I mean, then is the goal to resolve the bias in that model or simply
to detect it, but also to proceed with a model that is functional. Our previous model that was broke,
it had bias?
Well, it had bias, but also it the information acquisition, the loadings were broken.
Right.
We would not want to proceed with that model because information acquisition would be useless at that point.
In your stats package, when you do chi-square and it has a number of groups.
Oh, it's just 2 groups. Or 1 group. It's 1 group in this case. Yeah. Anyway, so since there is bias, what we need to do is keep this common latent factor as we move on to causal modeling. And what would you report? You'd report we did a method bias test with a common latent factor, and found that the unconstrained model was significantly different from the constrained to zero model. Therefore, we have bias, and we accounted for that bias when creating our factor scores. So let me just run this one more time, make sure it does work. One more note on this. Notice how I've connected the CLF also to the social desirability items. The idea is this CLF only pulls out the shared variance amongst all items. If there's something, if there's variance shared between the social desirability variance and the variance of like playfulness or anxiety, then that is the bias, and we're trying to extract that. That's the idea. So let's make sure these all still work. Oh, no, this is the broken one. Oh, that's right, because I restarted the model. Let me move this constraint.
So my chi-square difference test tells me that, yes, I am invariant. I don't need to bring the CLF along.
Yeah, if your p-value for the chi-square difference is not significant, then you can drop the CLF and the specific bias variables if you have them. Yeah, you don't need them.
Really, all I did was punch in the chi-squared for constrained and the chi-squared df for the unconstrained. And
Yep, that's correct.
that's what it's telling me.
Yeah.
So if the chi-square difference is statistically significant, you do not have common bias.
If it is significant, if the difference in the two models is significant, you do have bias. If it is not significant, that means they're not different, which means you don't have bias. Because we're trying to see if a zero bias model is the same as an unconstrained model. And if they're not different, then it means you don't have bias. Yeah.
And if they are different, you have bias.
Correct, you have bias that's more than zero.
Correct.
Yeah. So,
I'm sorry. So,
and why do we care? One more thing, why do we care is because we don't want an artificial inflation of our relationships due to some bias we weren't controlling for.
so whenever I set up my models, I automatically put the constrain the
Variance. Yeah, you constrain the factor instead of the path. Yeah.
So if I do that and the model still has bias, because that's how it's set up, is it better to move
You can try moving that constraint around to see if you can get rid of the issue. The primary motivation for moving a parameter constraint would be if there's a broken factor, due to the CLF.
And if I also have enough factors, I could simply eliminate that. I mean, if I have enough items on a factor, I could eliminate that.
You could eliminate an item if it's the one causing the trouble. Yeah, you could, if you have enough items.
So what does it mean when it's description metric at the model level? How are they being different? Half level.
Oh yeah, so we did a global method bias test here to see if the whole model was different or biased. We didn't check path by path differences. I wouldn't check path by path differences. If the model's not different, don't worry about paths. Yeah. Okay.
Take your word on it.
Yes. That's method bias. It's another one of the necessary evils of CFA. This is something more people will ask for than invariance. If you don't do invariance, probably no one's going to ask. If you don't do method bias, someone's going to ask. So make sure you do your method bias. Since we did define bias, now that we're ready to move forward with our causal models, we need to account for that bias. Here's how you account for the bias. In AMOS, you go to Analyze, Data Imputation. And what this does is it's going to, remember how in the EFA we saved factor scores? We're going to do the same thing now, but with the CFA. But this one will save the factor scores while accounting for the adjustment made by the CLF, meaning we won't be saving our factor scores that we generate for like anxiety or usefulness will already be adjusted for the shared variance that we're extracting out using the CLF. So then we're good. We have adjusted scores. Yeah.
It seemed like there wouldn't be any harm in retaining the common liquid factor even if you didn't.
So the question, sorry, there's a phone going off. The question for your remote folks who couldn't hear is, even if we don't have bias, what's the harm in retaining the CLF? If it doesn't break any of your validities on your factors, there is no harm in retaining that CLF. But it does add a lot of parameters to AMOS, which means you need higher sample size to account for, to accommodate it. Luckily, we have a high sample size, so we're fine. But that would be one reason you wouldn't keep it, is if it wouldn't run reliably with it. There's questions on the chat. Let's see. Did I get correctly that there was a test you made in order to see CMB affected the construct in a homogeneous way? Correct. We used a chi-square difference test between the unconstrained model. That's where the lines from the CLF to the items are not constrained in any way. And then we compared the chi-square in degrees of freedom for that model to a chi-square in degrees of freedom of a model where all these paths were constrained to be 0, meaning no bias at all. And if that test is significant, then means those two models are different, meaning it's not 0, there is bias. If it's not a significant test, then it means the model or the method bias is 0, so there is no bias. Tad says, what do you use if you do not have bias factor? Yeah, so if you don't have a social desirability bias or some sort of specific bias factor, what you would do is just throw in as many of the latent factors as you have in your data set. Even if they're not part of your model, throw them in there, because the idea is whatever is shared amongst all items is what you want to pull out. And so the more items you can throw in there, the better. They don't have to be valid factors. You don't have to put them through the EFA, the ones that you add for just that method bias test. So it's just to make sure you don't extract too much shared variance that's not due to method. That's what you do. Let's see.
And the one that we're going to impute is the unconstrained.
Yeah, we're going to impute from the unconstrained model, and we'll do that in just a sec. Raphael says, but does that also tell us if the bias is the same for all of them or if it is different? Ah, very good. So Raphael, you may have seen my equal variances. I'll show you in here. In the plugin, I run an equal constraints test to see if it's evenly distributed across factors or if it's imbalanced across factors. In our case, it was imbalanced. I bet it's heavier on information acquisition because that's the one that it broke. Let's see, he says, because I saw there are some methods that could work when the bias is the same for all of them, like the correlation approach. Right. The correlation approach is considered to be lower rigor. That's where you look at the correlations amongst the factors. And if there aren't any correlations above 0.9, then they're not sharing so much variance that it's going to inflate the relationships. But that's considered an older, low rigor approach. This zero constraints test is considered the most rigorous current approach. And that's method bias. So what you do from there, again, if you have bias, is using the unconstrained model, the one where the paths from the CLF are not constrained. You go to Analyze, Data Imputation. If you don't have bias, you can just delete the CLF and do the same thing I'm doing now. But you go to Data Imputation from Analyze, and it's going to create factor scores. Proceed. Zoom out. And there are different methods for creating those factor scores. You may recall in the EFA, these same methods were available: Bayesian, stochastic, and regression. There might have also been Bartletts option. We're just going to save a new file, and at the end of that file, it's going to be called _C for composites, or computed, or something like that. So just hit impute. And it's going to run, and it's going to say, hey, it was created, yay. Or it'll throw you an error. If it throws you an error, read the error. The error is pretty good. It'll tell you why it was an error, probably. And so, once you do that, we have a new data set in our Google Drive folder. data. It's this one, _C. And inside this one, you'll see, yes, you'll see we have new factors at the very bottom. Here they are, woohoo! And it named them for us. Everything that was a latent factor in our model, including the CLF, it created a factor score for. We don't need these three anymore. They've served their purpose. We now, all of these factors down here, these factor scores, account or already adjusted for method bias. The shared variance is extracted out of them. So you don't need to include them in your causal model. So I'm just going to delete them. Oh, escape. There you go. Right click. Clear. We also don't need the case number. That's just log purposes. Clear. And so now we have these factors that are now measured as scores, single variables, that we can include in a path model in AMOS. Yeah, nice complex path model. One more thing.
So are you saying you're now separating your measurement model from your structural model?
Yeah, I am. But I'm about to show you how to keep them together. So let's say you wanted to keep a latent measurement model while assessing a structural model, which is super complex, but doable. What you would do, oh, this is going to get so messy. What you would do, since we found that there was bias, is we're going to keep the CLF, we're going to keep the social desirability items, and then we're going to start drawing, well, we'll start deleting actually, covariances. Let's look at our model real quick, which is over here. Playfulness and anxiety are our only exogenous variables, the only ones that aren't being predicted. So where you need to delete all of the covariances from all of the latent factors except those two. And also social desirability one. It's because we're not going to predict them. So we'd go over here, hit the X, and everything going into useful, get rid of those covariances. Whee. Anxiety, playful, those are the two, right? Yep, so we'll keep that one. But we'll delete all of the ones that are not. There we go. We'll keep the outer two here, but delete that one and that one. Pixel perfect. There we go. The reason we're deleting these covariances is because we're going to predict these latent factors, and you can't predict something that's also being covaried, not in AMOS. Okay, so we end up with that. And then we would start drawing single-headed arrows to the things that are being predicted.
Should playful be connected to?
Oh, it should be connected to the social desirability. Thank you. Yeah. Playful to social desirability. 1 and 2. Good catch. Okay. You can see why you might impute factor scores and do it in the unmessy way, because this is about to get crazy messy. Our dependent variables are information acquisition, decision quality. So everything is going to predict them. So usefulness goes to decision quality and to information acquisition. Oh, but since we're constraining information acquisition to its variance to 1, we have to get rid of that because you can't predict something that has its variance constrained. You can see how this gets pretty crazy. Stick a 1 instead onto a path constraint and hope it doesn't break it. And carry on, predicting. Usefulness predicts information acquisition. Anxiety predicts usefulness. Anxiety predicts decision quality. And anxiety predicts information acquisition and comp use. This is really nasty. What we might try to do is move them, but they're all connected to the common latent factors, so it gets kind of messy. Go like this. Again, you can see why you might want to do this as factor scores instead. So that's our model without all the arrows in yet. Playful predicts this. I hope you're not doing this with me. It gets really messy, and I'm not going to do this for real. I'm going to do factor score version. Once you did that, you'd have to add error terms, that's this box circle thing, to anything being predicted. Because there needs to be error anytime you're predicting something. And what we'd have to do is name all those errors, which you can do with a plugin, built-in plugin, just called name unobserved variables. And then you could run this. It's a mess, but you could run it. So if I hit run, proceed. It's crazy complex. It iterated 43 times, which is a lot. More normal would be 7 to 12. Decision quality looks broken, or one of these looks broken. It's information acquisition again. It has negative loadings. You probably can't see it. It's like, it's a mess. Can we do it the other way? Is that all right if we just do it with path? But yeah, this is how you do it. This is how you do it by keeping it latent. It's kind of a mess.
What are we doing? Sorry.
Somebody asked how we would keep the measurement model intact while running the structural model. And that's how you do it. It's a mess. So I'd rather not. What I'd rather do is use the factor scores. So file new. No, don't save. Ugh. There we go. Fresh slate. So do this with me now. Whoever is following along. The data file should be available in Google Drive, the one that's called _C at the end. And we're going to link that data set. Data files, go find the data set. The _C data set. Is that file available? Is anyone using that file? You're probably using your own, yeah. Are you using this file? Yes. No. No. All right. So I'll just go ahead, assume you're following along with your own data. So if you've connected your data set,
So now, sorry.
Yeah.
Now you're doing your structural model.
We're
You're doing it in Amos. Other
Yeah.
people might do it in Plus
or Smart PLS. So what we could do, yeah, I've been thinking about this. What if we did Amos, we build our model, run it, then M+, we build our model and run it, and Smart PLS, we build our model and run it. Would that be a waste of time for most people, or would that be better for most people?
Depends if you're paid hourly.
I'm going till 5. Yeah. So, yeah, helpful. Just so you can see the 3 different software programs. I assume most of you won't be using M+. Well, I guess you 3 will. Who's going to be using Smart PLS? You 2. And then Amos, you'll be watching and doing maybe. Okay. Okay, so this is big spectrum here. So we'll start with Amos, then we're going to do Smart PLS, then we're going to do M+ in that order each time. Okay, so let's just build our model in Amos. And the way you do that, you connect your data like we just did, and then you click on the white stacky thing, and you pull in your variables that are at the very bottom of your data set. For us, it was comp use, information acquisition, decision quality, playful, anxiety, and usefulness. Something like that. And then in Amos, you have to covary anything that is not predicted, like that. And then we'll draw our predictions, which our model looked like this. Essentially, everything predicts everything. No connections there. So like this. Now the path model doesn't account for measurement as well, obviously, or error, measurement error as well as the full measurement model with the latent model. But it does a decent job. Okay, so you should have a model that looks something like that, and then you'd have to add error terms to anything that's predicted. That's this box with a head. or circle on top of it. You click on the objects there. And then you plugins name unobserved variables. That'll name the errors. I'm going kind of fast. Are you following along in this one, or are you just watching?
Yeah, I'm trying to follow along.
You're amazing. Okay.
I'm close.
Oh, very good. Okay. So then I'll wait for you. It's fine. Let me know when you're up to this point. Remote folks, I hope you don't mind. I'm going to do M+ and Smart PLS today also. Whoops. Let's see. And we'll do them just sort of in sequence. We'll do a regular model in Amos, and then build the same model in Smart PLS, and then build the same model in M+. And in Smart PLS, we use the latent model. It's a little easier to use the measurement model in Smart PLS than in Amos. In M+, we use just the imputed factor scores, not a latent model, because that gets really complicated. You're good? Okay, so we have our model. We're going to go to analysis properties, the colored abacus. And yes?
Why didn't you draw an arrow between anxiety and info acquisition and decision quality?
Oh, did I miss those? Whoops. Oh, yep, I just missed them. Oversight. So let me go put those back in. Thank you for catching that. There we go. That's better. Okay. Analysis properties, output.
Another thing.
Yeah?
From anxiety to decision quality and playful to info acquisition?
Oh, did I miss some?
No?
In this model, it doesn't show that. So we'll just pretend we're good. Except it's opposite, isn't it? Haha. This is supposed to be playful. This is supposed to be anxiety. So I messed that up. So let me just move those arrows. In our model, it goes like this. Like this. Okay. There was a text chat. Oh, any need for controls? Yikes, yes. Our controls, at this point, we want to add them in. Thank you for catching that. Our controls are age, frequency, and social desirability. We already controlled for social desirability by including in our measurement model and adjusting our factor scores with them. But we need to include, what was it, age and experience? Nope, age and frequency. So we need to drag in age and frequency. Here's age. Here's frequency. Ooh, that's big. You can double click it and just delete its label. That'll get rid of the bigness. Or at least it's a lot of wording. You can resize it if you want with this resizing thing, blue box with arrows. There you go. And we can move it around. Okay, so these are our controls. The way to control for something in Amos is to treat it like an independent variable. So we draw arrows to the things we want to control for its effects on. Which things should we control frequency for? Do we think the more frequent you use Excel, the better decisions you're going to make? Yeah, I think that makes sense. The more information you're going to acquire? Probably. The more comprehensive your use will be? Probably. The more useful you'll find it? Yeah, probably. How about age? Better decisions by age? Maybe. Maybe. In fact, these might all be connected, yeah. And then, now that we have a good thorough mess, you need to covary these because they are exogenous. And covary them with these ones so that everything is covaried that is exogenous. Well, a good mess. So those catching up. We added age and frequency as control variables because we want to account for their effects on our dependent variables or any predictive variables. And we covariate those controls with our independent variables because that's an assumption of covariance-based SEM. Questions on that? Sort of went swiftly through that.
Okay, so
Yeah.
playfulness, okay, you just have it backwards from the diagram.
I did. I put playfulness in the wrong spot. Sorry.
That's me.
Yeah. Okay. So we're controlling for their effects by just allowing the regression to occur.
So do you consider computer use and useful as mediators?
Yeah, they would be mediators in this case.
And do you have any limited number of mediators in the model?
In this model, we have 2 mediators, but you could include as many as you want, as long as sample size permits it.
And there's no limitations to then, like, is there any formula for like dependence compared to mediators, compared to independent variables?
Yeah, the way we treat them will be a little different, and the way we interpret them will be different. When we get to mediation, we'll definitely cover that.
Is that today or
Yeah.
tomorrow?
Hopefully we'll get to that today. We have about 2 hours, so we're going to try to get to that today. So the next thing we need to do is go to our analysis properties, the colored abacus, go to the output tab. We want to see standardized estimates, obviously. We also want to see squared multiple correlations. This is just the R squared. Another good thing to see is modification indices, just in case there's some path we're not accounting for that we should be accounting for, if model fit isn't very good for some reason. And there are other things we can do later, but let's stick with those for now. And then just close that window. Let's save this as our path model, maybe path initial or something like that. Yes, I'm going to overwrite it.
And where did experience go?
Experience is not included right now. So you see in our model, experience up here as a moderator. I have not yet included experience as a moderator. I'm going to run a base model without the moderator and then add the moderator in. Although you could run the full model all at once. That's one way to do it. Yeah, that's one way to do it. Okay, so let's run this. Hit the up arrow, and then make sure we're looking at standardized estimates, and then we can start interpreting things. Whee! So, on the top right of the predicted variables, you'll see the R square. So, information acquisition, we're predicting 32% of the variance in information acquisition. That's the R square there. And 27 in decision quality. The number on the line, that is the slope of the line. That's the regression weight or path coefficient. You'll see these are standardized, so 0.03 is not very epic. Not much going on there, but you'll see this 0.31, that's pretty good. Playfulness to information acquisition, pretty strong effect. 0.36 here, that's pretty good. Now, are they significant? If only it would tell us. It doesn't tell us until we get into the output. So you can go to the output, look at the estimates, and then you can see the p-values right here. Here's the p column. If it has a star, 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 that means it's less than 0.001. And we can see some of these effects are significant, some are not significant. If we had a hypothesis that that while controlling for age and frequency, comprehensive, or let's see, usefulness leads to better decision quality. That would be this one right here. Then we would say, yes, supported. Almost. Almost. There's more to it. We have a significant p-value. We have a beta in the right direction. It is substantial. If we go down to the standardized regression weight down here, usefulness to decision quality, that's a pretty substantial standardized regression weight. The question is, do we have model fit? If we don't have model fit, then we can't have confidence in the model we have. So first we got to see model fit. We look, oh, dang. CFI is 688. We don't have model fit. So let's go look at the modification indices. See which major relationship we didn't account for. Oh, here it is. Information acquisition and decision quality, highly related. So we need to account for that relationship. What do we think? Does information acquisition lead to better decisions, or does decision quality lead to more information acquisition? I think it's top to bottom. I think it's the first one. So I'll down arrow this. I'll include a regression line. Tell me, are we going to hypothesize this new line? No. We're controlling for it. That's all we're doing. We're not changing our theory. Here's our theory while controlling for the effect from information acquisition to decision quality. We've not changed our theory. We're accounting for potential effects that if we didn't account for, our model would be invalid because we don't have model fit. We run this again. We look at the model fit in the output. CFI 984, that one path bumped us way up to 984. We are good. If we want to look at the other things we can, P close, we're close, and RMCA, we're close. We're probably good enough for now. This is good. If we look at the modification indices, there might be something else. There is. Decision quality and playfulness are somewhat related. Not a big deal. We have good enough model fit. So all of that preceding stuff led up to this, and we just ran our model and we're good. There's more to it though. You can do mediation, moderation, multi-group, all sorts of stuff. So let's do that also. What we're gonna do, I'm going to run through this in Smart PLS. Those who are totally not interested in Smart PLS, feel free to zone out. And then I'm gonna run through it in M+. Feel free to zone out if you're not interested in M+. There's one more chat up here. How do we know that social desirability rightly accounted for CMB? We don't. Is the choice purely driven by theory? Yes. What was the name of the method we used to account for CMB? The method we used was the common latent factor plus specific bias test. I don't know if it has a specific name. There aren't any really good papers on it. But essentially, we just use a chi-square difference test between the model where it's constrained zero bias and unconstrained bias. That's the test we used, chi-square difference test. Excuse me. Okay, the marker technique. Yeah, some people call the specific bias test a marker technique, but marker is where you take an unrelated, a theoretically unrelated latent factor and use it as a quote-unquote marker, like we use specific, like we use the social desirability bias factor. But the marker technique has some serious limitations that have been published about. It's hard to find a theoretically unrelated variable, and when you do, it often breaks the model. But it's still better than nothing, sometimes. So, yeah, but there is a marker technique. If you look at the Podzikoff and McKenzie articles, they talk about it.
Can you please explain again, how did you get the suggestion to draw the line between info acquisition and the other?
Oh yeah, sure. Yeah, so we had terrible model fit. So in the analysis properties, we check the box for modification indices. And what this will do is it'll look at the model and all the parameters we did not estimate. And it'll see how the model would change if we did estimate them. And then it suggests the biggest ones, the ones that will affect the chi-square the biggest. So when we run the model, we can look at, that output in modification indices right up here. Modification indices. And it will tell us, here are the big relationships you didn't account for. So here's one left that we haven't accounted for, playfulness to decision quality. It's not that big though. Oh, excuse me. That's how we get that. That's how we made that decision. And again, we're not theorizing from information acquisition to decision quality as some major relationship. We're just accounting for its effect so that all the other relationships we can look at are valid. So now if we ran our model and looked at the relationship between usefulness and decision quality, Notice it's cut in half. It used to be 0.44 in the standardized effect. It's now 0.22. It's still probably significant, but it's not as big, but it is now valid, which is nice to have valid. We can have confidence in that estimate, whereas before we couldn't have confidence in that estimate. Also notice our R-square on decision quality is about doubled to 56.
Shouldn't some of those issues be identified as multicollinearity and just a,
Oh, we haven't even looked at multicollinearity.
I mean, between indicators though in your bivariate correlation table?
Oh, between indicators.
Between indicators, yes.
Like at the measurement level?
For one that you know is going to be, you know, part of this latent construct versus one from another latent construct.
You mean at the measurement level?
I mean, just as an initial look at your data to see if you're going to have.
Or if we're going to have issues later on.
Yeah.
So hopefully we see that in the EFA, which we sort of did. We saw that information acquisition, decision quality were highly related. And we saw that in the correlation matrix later on in that EFA. We saw it again in the CFA when we saw the correlation matrix. And so it was like 0.68 or something like that, 6.9. So yeah, we saw it coming. We just didn't theorize about it. No. Okay, one more chat here. Let's see. Oop. Should we delete the control variables to evaluate the model fit? No, you want the model fit to include the control variables because they're part of our model when we're testing our hypotheses. So every time you test a hypothesis, you want to test model fit. But if your hypothesis requires controlling for effects of potential confounding variables, then you want those included in the model fit test. So in this case, yeah, we want age and frequency just always in there. Okay. So that's how you set up a model in Amos, a path model. I'm going to show you how to do it in Smart PLS.
Okay, so
Yeah.
you controlled for a causal relationship between information acquisition and decision quality.
Yes.
And you didn't try the opposite.
I didn't, because I theorized, I thought, you know, it's probably from information acquisition to decision quality. Just makes more sense to me that the more information you acquire, the better decisions you can make, rather than the better decisions you make, the more information you acquire. Temporally speaking, it seems information would come before decisions.
Okay, but what if you tried the other and you got an even better fit?
Oh, I guess you could. I doubt the fit would be drastically different, and I'd rather have a non-theorized path be based on theory as much as possible.
Okay.
Yeah, so that it's not just a statistical anomaly we're accounting for, if that makes sense. Yeah, we could switch it around and see, but I bet we'd have almost identical results in terms of model fit. Yeah. Okay. Anything else in Amos before we switch over to Smart PLS? We're going to come back to Amos to do mediation, moderation, multi-group. But we're just going to set up a model in Smart PLS real quick. Anything else here before we run to that one? Okay. Here's Smart PLS. Everybody who wants to follow along, I sent you a license. Hopefully you installed it. Hopefully it's working. I'm going to trust that it is. And if it isn't, you'll just have to watch instead of follow along. Open up Smart PLS if you're going to follow along. And it takes a moment to open. In terms of interface, I like Smart PLS the most of the three we're going to use. It's quite intuitive, pretty easy. Hopefully it opens. Come on, there we go. So when Smart PLS opens, you'll see, like with Amos, it's just a blank canvas. Can't remember, you're following along, Scott, are you following along as well? Okay, so just give me nods as we go through if you're where I am. The first thing we'll need to do is we'll have to have data that is appropriate for Smart PLS. Smart PLS only accepts .dat and .csv files. So in order to get our data to that point, we'd have to go into SPSS. Is this the one? Yep, Boot Camp, original, no missing, trimmed. What we'd have to do is save this and then save as. And I'll just do this so you don't have to do it. And I'll save it in our data folder. And we're going to save it as a .dat file or a .csv. Let me do CSV. easier to manipulate. And we'll call this Boot Camp PLS. Oh, I have one in there. Look at that. There's a Boot Camp PLS. Let's use that one. It's already there. Okay. So we have a Boot Camp PLS in the data folder already loaded in. In PLS, we can now create a new project by going to the New Project button up top or File New, Create New Project. Name this project whatever we want. I'll call it Boot Camp 2019. Spaces are allowed. Just so I know, remote folks, are any of you like following along in Smart PLS and want me to paste it to you? Or are you just watching? Just watching. Okay. I think Tad was the only one who said Smart PLS is one he was looking at. Okay. Good, good, good. Then I'll paste it to the folks locally here. Okay. So you now have a new project. Now we need to double click where it says to import data, double click. We're going to double click to import data. So double click that. It'll open up an open dialog. Got to go find that data. Mine is in the Google Drive data folder. And Boot Camp 2018 is what I'm going to use. Yep, that'll work. So just from last year, it's the same data set, same thing we've done here. Hit open and hit OK. So now we have data and it's thinking through it. Does not like some of our data. Nice.
Is it because Boot Camp 2019 is already in there?
No. So let me just replace this data. We'll let me try a different one. If it doesn't work, then I'll create a new one. So let me just delete this one. Deleted. Double click. We'll grab Boot Camp Missing. I'll just grab the most recent one. Here it is, Boot Camp Missing. Open. See if it likes it. It likes it. Okay. Use the Boot Camp Missing if you're following along, or use your own data. And so Smart PLS automatically generates the means, median, min, max, how many are missing, standard deviations, skewness, kurtosis, all that stuff, just automatically for you on all of your indicators, which is kind of nice. But we don't need that right now. We're going to assume it's all clean. Back in the Boot Camp model, double click that, double click the Boot Camp project model, and a new tab should open up here. And pretty colors on the right. What we're going to do is we're going to build our model by using the latent variable tool. And we're going to click, 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 because we had two independent, two mediator, two dependent variables. And then we had those two control variables. We'll just stick those over here. Yep. And then we just need to name them. The way to name them, switch from your latent variable tool to a selection tool. Double click, oop, don't double click. Single click and hit F2, or right click and hit rename. We'll call this playful. Doesn't like that, hit OK. It's been a while. Anxiety. Comp use. Useful info acquisition, decision quality. Oh, if you right click them and go to rename, or just single click them and hit F2. That's what I was doing. I assume you already have a model built. And then Scott, are you following along with this one?
No, I'm just going to watch you.
Okay, cool. So then I can go at, all right. Then I'll go at a nice pace, a nice fast pace. Okay. Then I'm just going to rename all these then. Frequency. And the last one was age. Okay. And now what we need is to bring the indicators into each of these latent factors. So let's see, playful. Let's go down to playful down here. There's playful. And I recall we kept all the items from playful, 1 through 7. Just drag those into playful, which is kind of nice. And then anxiety was back up at the top. Anxiety 1 through 7, we kept all those. And then compuse, here it is, 1 through 4, we kept all of those. And then useful, here you are, 1 through 7. Drag those in. You can see the interface is pretty nice and seamless. Did I miss decision quality? Oops. Down here, decision quality. Now we dropped 6. We got 7 through 10 and 12. Decision quality. Information acquisition, we had all 5, right? I think so. I can go back. Yeah. Okay. And then notice with age and frequency, we only have a single indicator for these. You will just use those single indicators. That's a little different from Amos. So bring age in to age, and it's just a single and frequency over here. Okay, last thing to do is connect them. You can also switch things around so it's not so messy. So you could right click and say, put the indicators on the right. And I could say down here, put the indicators below. Or I could use this interface over here, let's see, top, yeah. And then I can also hide them, like frequency and age. I don't need to see those indicators, so I can just hide them. Right click and select hide. And then using the connect tool, just click and click and click and click. Oh, click and click. And keep going, click, 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 click. There we go, and then control for frequency. We do not need to covary anything because this is not a covariance-based software, and so it doesn't require covariances. Notice things turn blue as soon as everything was connected to something. And that's all it needs. Let's, oh, I forgot these. Okay, and then last thing, let me shift this over to the right. Okay, this is ready to run. Nice, easy setup, and it's all pretty intuitive. You hit calculate, and there are several different options in calculate. There's the PLS algorithm. In Amos, we were running the maximum likelihood algorithm for SEM. This is the different algorithm that's not based on the covariance matrix. It's based on a components matrix. There's also consistent PLS, which I don't recommend running ever. It still has some bugs in it. But the reason you would run it is if you had all reflective factors, which we do. But it has some bugs, so I don't recommend running it.
So even with all reflective,
Go with a PLS algorithm. We can try consistent and see if it doesn't give us bugs. Maybe we'll try it.
do you know if it's giving you a bug? Like,
Oh, it'll be obvious if it gives you bugs because it'll have like errors in the output. Yeah, so maybe we'll try it. Bootstrapping is for when we want to do we want to find significance of effects. So I'll just run the regular PLS algorithm, PLS consistent, I guess, since we have all reflective measures. It's going to say, what are your settings? Since this is all reflective, we could connect all latent variables for initial calculation. And we want to look at the, well, it depends what we're doing. There's a path approach or a factor approach. There's also a centroid approach. Path approach is when you're examining the inner model, the relationship between latent factors. Factor approach is when you're assessing the measurement model, the outer model. So let's, real quick, let me show you the factor loading. We'll assess the outer model. Essentially do everything we did yesterday, but super quick, and it's a CFA, so I guess everything we did this morning. So when you run it, it creates a report, and all the options for the report are down below. We can assess the outer model real quick, looking at construct reliability and validity, and it produces the tables for you. Isn't that nice? And color codes them. Here are the Cronbach's alphas for all of these factors. If they're green, they're good. Here's the ABE for all of these factors. If they're green, they're good. So we're good. The ones, those are for the single item ones. I don't know why useful is a one. That's probably because we're using PLS consistent. So there's some bugginess to it. So I'd rather just use the PLS algorithm. Try that again. Hit start. And now we can look at construct validity and reliability. We get the same output. Okay, so maybe it's not a bug. Maybe we just have really good factors. We look at Cronbach's alpha in terms of a graph. It gives us graphs. They're not super pretty, but they're there. We can also look at discriminant validity. It'll give us that same correlation matrix that they produce with the square root of the ABE on the diagonal, just like mine does. And it would produce an error, a red, if there were any problems. Looks like there are no problems. You can also look at the heterotrait monotrait for discriminant validity. Lots of reds. That means there's a lot of overlap between our factors. That is unfortunate. These numbers are way higher than I expected. I wonder if it's an artifact of the data we're using. Anyway, you want these heterotrait monotrait values less than 0.9, ideally less than 0.8. If they are red, that means you cannot discriminate between the factors. So we're using a data set from over a year, or from a year ago, and I'm not sure about the quality of that data set. So I'd have to go look into this. This isn't the one we validated here at our boot camp. Anyway, but that's how you would look at factor reliability in PLS. As for looking at the model, you'd look at the R squares. Yeah, there's definitely something weird going on here. Yeah, R squares of almost 1. There's something funky going on in this data. I'll have to try some other data, but for now we can interpret it as if it were real. The R square is found in the middle. It shouldn't be almost 1. That's wrong. The loadings are right here. Also shouldn't be almost 1. There's something wrong there. And the path coefficients, they are on the path. Those are standardized regression weights. To find out if they're significant, you can do calculate and do bootstrapping, and that'll produce a critical value for those path coefficients. Let's see if this fixes our weirdness. Here's the table it produces for you for every path. You can see the p-value for each of those paths and the sample mean of the regression, the coefficient, the regression coefficient. And these look more normal. I don't know what was going on with that initial run. That was weird. But if we want to look at something in particular, like usefulness to decision quality, we can see that effect averages out at about 0.299, and the p-value is significant. So that effect is significant, assuming we trust our data. I'm not sure I trust this data. But that's how you'd interpret it. And that's smart PLS. We didn't do mediation, moderation, or anything yet, but that's how you set up a model and get it running. Let's do this. Let's take a 5-minute break and then run it through M+, and then we'll go back through and do mediation, and then we'll go back through to moderation. Whew. And I'm going to look at this data real quick. This is weird. I might just use the data we created. Let's see. I'm going to use this one. Yeah.
So the factor weighting scheme should be used to assess those outer loadings.
Yeah. And then for the inner model, we should have used path, which we didn't switch to. We should have. All right, I'm going to pause the recording, and we'll start back up in about 5 minutes. Zoom recording. All right, we're back. So I put the other data in from this year, and it works just fine. The question was, how do we validate factors, formative factors in Smart PLS? Let's go to our model here, and let me pretend I have a formative factor. let's pretend for a moment that comp use is formative. The way we model that is you right-click the factor and you switch between formative and reflective. There's an option there. And what that's going to do is it's going to switch the arrows around so that the arrows point instead of from the latent factor to the items. It'll just point from the items to the latent factor. So you see these arrows turned around, and now it is considered to be formative, and now we can run it with a PLS algorithm, not PLS consistent, because that's only for all reflective models. We run it. We're going to look at the factor weighting scheme since we're trying to validate a formative factor. Hit start, run, and we're going to do a couple things to validate that formative factor. The first is we're going to look at the estimates. Well, to do that, we have to do a PLS bootstrap. So I guess the first would be look at the collinearity diagnostics down here where it says collinearity statistics. Click on that. Let me zoom out. And we want to look at the outer model, but we're only interested in the outer model for comp use. And so here it is right here. And you can see these are just fine. They're less than 3.3, which means they are not too extreme. They are not overlapping too much. The dimensions are unique. We also want to look at the t-scores for those, but to do that we have to bootstrap. So we go over here, go to bootstrapping. We'll just do 500 for now, nice and easy. Hit start. It runs. We look at the p-values for comp use. Let's see. It's going to be not inside here. Let's go back to our model to see them. Here you go. These are the t-scores, the t-values, the critical values. Notice anything above 1.96 is considered significant at the 95% confidence level. Anything above 1.65 is good at the 90% confidence level. So we have a strong indicator over here, but that's it. So this is not a particularly good formative factor because 3 of its indicators are not significant predictors of the factor. So if this were truly a formative factor, we'd probably see some better numbers, but it is not truly formative. And I don't have a formative factor in my model right now. But that's how you do it. Look at the t-scores, see if they're significant, and look at the VIFs to make sure they're not multicollinear. And that's one way you can validate the formative model. Okay, I'm going to switch this back around so it's not formative because it's not. We're going to go to we're going to go to M+ now. Whew.
Yay.
Okay, those who are totally not interested in M+, feel free to zone out. In order to go to M+, I need to virtualize. All right. To virtualize, I need to go here. Let's see. Citrix receiver. Log in. And open up M+. So M+ is fully syntax based. You cannot draw a model, although it will produce a model if you ask it to. Because it's fully syntax based and we don't use it every day, I have created syntax examples to use with M+. Those can be found on the stat wiki in the M+ section. Here's M+. Should I just run through things at my pace, or are people going to be following along step by step? Stumbling along step by step. Okay. So on the stat wiki, there is a YouTube playlist for M+, if you get lost, and syntax examples, which I will open up.
And why do we like M+?
Yes, that is the question of the year. Why do we actually like M+? M plus is considered to be a more versatile software for SEM. There are two things in Amos that don't work well. One is interactions. They don't calculate precisely. The other is multiple mediation. When you have multiple mediators, Amos does not automatically calculate the indirect effects for each specific indirect effect. It aggregates them. I've written a tool that de-aggregates them, that matches M plus precisely, but I haven't written a tool for interactions with Amos yet. Okay, I'm going to open this up in Word. Not going to let me, so I'll open up my version. Let's see, M plus syntax examples. Here they are. Bunch of resources in here. I assume we'll start with just building a regular old path model. Okay, path modeling, simple linear regression. I'm literally just going to copy this syntax and replace pieces of it. Or I could type it out and we could explain each piece of it. Maybe I'll do
I think copying and explaining.
copying and explaining? Okay, let's do that. All right, where'd you go? Where'd you go? Where'd you go? I gotta find my Citrix server. Here we go. So, I'm gonna paste this in here and I'll explain it. Can I Control plus? Can I zoom in? Can I view? Edit, format, text, change font so everybody can see it. Let's choose the font to be size 24. Okay, that's a little better. Okay, a little. I'm actually gonna make it a little bigger. Edit, change font, make bigger, 48. Okay, that's visible. All right. So M plus, again, it's fully syntax based. The way you start is you tell it what the name of the thing is you're creating. We're creating just a simple path model. I'm just going to call this Path Initial Boot Camp 2019. You can call it whatever you want. Then you have to tell it where you're going to get the data set by saying the file is, and then name the data set. We got to create the DAT file. Let's go. Huh? You already created
We followed along whenever you created the DAT file.
Oh, you did?
PLS.
Cool.
Right?
I didn't create a DAT file. I'm going to create a DAT file right now.
I'm looking at right?
Now I'll create a DAT file in SPSS. So file, save as, and we went to save as.dat.
I mean, it's the same, right, as what you did with PLS?
Yeah, except I use it .csv for that one.
Oh. Okay.
Yeah. Also in M plus, you can't write variable names to the file. It doesn't want variable names. So you got to uncheck that. Ooh. We need to make our life a little easier, actually.
Yeah.
Cancel this. What we need to do is only use the factor scores, because otherwise we got to bring in all of the measured items. Yeah.
Right.
So yeah, you have to name. So let me explain. So when you load a data file into M plus, it doesn't want variable names for some stupid reason, and so then you have to name every single variable in order. Don't make a spelling error. Don't name your variables too big, more than 8 characters. And anyway, it's
So open up.
amazing.
So we should open up the SPSS file, the imputed file that we created.
The imputed file, the _C, is what we want to open up.
On our machines, not
On your machines. Yep.
Okay.
And then get rid of all the variables that we're not actually using. Which would be all of this. Wait, no, we got to keep experience and gender and frequency.
Experience and education.
Yeah. But also keep gender and frequency. Oh, well, for your model, I don't know, but for mine, Yeah.
Frequency not. Okay, wait, so get rid of all.
Get rid of everything that's not going to be in the model. Yeah, and then save it as something else. Don't overwrite your original data set.
And you don't use variable names.
When we save it as .dat, we don't write variable names.
You have to move it.
You need to go back.
So in SPSS, you get rid of every variable that you're not going to use in your model,
Including the CLF.
including the CLF.
In your
Yep, everything. But keep your controls, keep your interaction, keep your moderator, keep your multi-group.
What is control case number?
You don't need case number.
Is that like a
It's generated when you do the impute factor scores.
1, 2,
Okay.
all right.
Okay. So when you do that, save as, and you're going to save this as something simple like 2019 Boot Camp, and you're going to save it as a .dat file, but make the encoding local, and don't write names to the file. Yeah, I'm zooming in here. Make encoding local, and don't write names to file.
Why doesn't it give you the encoding?
Yeah. I didn't-
Change to save as type .dat.
First. Okay, whoops. Can I use dash and find?
Yeah, you can, but I wouldn't recommend it. Use an underscore instead.
Tab, local.
Yep, and then don't write variable names to file. Okay, save that. Where do I want to actually save it? We'll save it there, that's fine. All right, save.
Where should we save it?
Ideally, save it in the same folder as the input file you're creating. Oh, I got to create a file name for M+.
Oh,
We have
where?
to move it to your.
So where is that?
That's on the H
On
drive.
Citrix?
Yes.
Yeah. It's on the H drive.
That's
Yeah.
just like hard. I don't know.
And I don't know how to access that. So I'm going to save it in this folder and see if I can navigate in Citrix to it.
Wow.
So we'll see what we can do. All right, this is let's see, 2019 BC M+, something like that. Okay. Save.
All right, now I have my name. Yay.
Okay, so we now have a DAT file, hopefully. Then back in M+, we have to find that DAT file relative to where we currently are.
And that's the question.
Where are we? In order to find out where we are, I hate M+. Hate it with a passion. What you'd have to do is go back and go to your virtual desktop, which is in the Citrix receiver,
Workspace.
desktop, and Wasm Virtual Lab, if you're using that one. Another reason I do this is so everybody else can appreciate how good Smart PLS and AIMS are.
Ooh, you sound like a hater of M+.
He just said he hates M+.
With a passion.
He just said.
Are you not paying attention?
No, sorry.
So you don't. Okay, so. How do I?
I'm rethinking this strategy. Might have been faster to do a Smart PLS AIMS side by side and then do a separate session for M+. That's all right. We're almost there.
Try.
Okay.
So. What's happening on your screen?
I'm loading the virtual desktop. Did you click on the Wasm desktop?
I did.
Okay, and it's loading, hopefully.
It asked for my password.
And you remembered it?
I did.
Oh, good. Oh, and then I can just go to the Google Drive folder. Question from Ted. Do Amos and Smart PLS accommodate longitudinal analysis? The answer is sort of. Not explicitly. You have to do some funny things with them to make it work. What is it loading for me? Yikes. No, I just want to go to Google Drive. Drive.google.com. I think this is what we're going to do. We're going to toggle between Smart PLS and Amos, and then we'll have a session on M+. As soon as we finish those. Let's see, we have an hour. Yeah, what we might do is we can either finish out the day with Smart PLS and Amos and then start M+ tomorrow morning. When do you guys leave? Okay. And then, but if we finish Amos and Smart PLS today, then whoever's not interested in M+ doesn't have to come tomorrow.
So we can go and just watch the videos and come fresh tomorrow.
Yeah, we could do that.
We can all be smart about
That'd
it.
be fair.
How does that sound like a plan? So tomorrow, if you're not interested in M+, don't even have to come. Not that you have to come. I mean, anyway.
You could come and learn it.
Yeah, because you see how fun it is.
We're all doing
It looks super exciting.
Okay, so let's do that. We'll do M+ in the morning. Let's finish out Smart PLS and Amos right now.
Okay, so we're gonna get off of Citrix and come back tomorrow.
Yep, that sounds good.
Working with you.
Okay.
Forever.
All right, so back to Amos. Let me close out my Citrix M+ here. Close that. No, don't save. There we go. Okay. Back to Amos. So last time we finished calculating just the initial model. What we want to do now is look at mediation. So in Amos, it aggregates mediation when you have multiple mediators. Mediation is just the indirect effect between one variable and another going through some other variable. It's to say that, for example, let's go down here. Usefulness is part of the reason playfulness affects information acquisition. It's just, it's either all the reason or part of the reason. We're theorizing is part of the reason playfulness affects information acquisition. It's because when you're playful, you find things useful, and when they're useful, you get better information from them. I'm just making this up as we go. But that's what it means, theoretically. And the way we test that is through an indirect effect, which is literally just multiplying this effect by this effect over here. These two lines, you multiply their regression weights. But Amos doesn't do that for you, so you have to do it with an estimand, which we can do with a plugin if we want. Makes it a real pretty table. So if you were to go grab this plugin, indirect effects, DLL. Download that one, stick it in your plugins folder. And there's actually one more step we need to do after you do that. Who's doing that? Just so I know you are doing it. Okay, and you're doing it. Okay.
James,
Yes. Yes.
is there a way to go around the plugins? I tried that. I downloaded it. Doesn't work. Crashed my computer.
All right. Yeah. There's a way around it. There's an old-fashioned way. Use estimand. Let's do the estimand instead for you. I'll show you. If you go into our folder, our plugins and estimands folder, and you go instead into the estimands folder instead of the plugins. Go into estimands. You can download the My Indirect Effects estimand, and you can put that anywhere you want on your computer. It can just be in your downloads folder. That's totally fine. It doesn't have to be in any specific folder. So grab the My Indirect Effects estimand, stick it anywhere. Just make sure you know where you stuck it. And let me know when you're there. The rest of you, you two who are following along, you'll also need an estimand. You'll need the specific indirect effects estimand Again, you can put that wherever you want. It's this one right here, specific indirect effects, because that is used with the plugin. And you, again, you can stick that one anywhere. Was it Maria who was following along remotely doing this with the estimand? Someone? Lori, was it you? Was someone following along with me remotely, wanting to do it with the estimand, not a plugin?
It's me, but I will do it later on because I'm afraid to do that, and then my computer will not react
Okay, then
properly.
I'll just show you real quick, and then you can do it later on. So,
Yes, please.
okay, sorry, I was waiting on. Here we go. So what you would do if you weren't using the plugin, you would hit the down arrow, and you would name this path parameters capital A, and name this path capital B, and then you would, down in the bottom left, there's this little thing that says not estimating any user-defined estimand. You would click on that and select an estimand, and it would be the one you downloaded. Where's that window? Here it is. It'd be the one you downloaded called My Indirect Effects Estimand, and you hit open, and now it's estimating that, and that estimand, it's expecting to find two paths, one named A, one named B, and it's going to multiply them. In order to use this, you also have to be bootstrapping. So you go to Analysis, Properties, Bootstrap, perform the bootstrap, and then use bias corrected intervals, and close, zoom out, and run.
I put 2095. Is that okay?
Yeah, that's fine. Yeah, that's great. I just did 200 for the sake of speed. And when you look at the output, there will be a new section in estimates, matrices, scalars, sorry. And the new section in scalars is called user-defined estimands. And it produces this little table right here. And if we open it up a little bit, clicking down over here, bias corrected percentile method, then you'll see that the A times B, the estimate is 0.17, and it is significant. P is 0.016. That is the specific indirect effect, not being muddied by the other indirect effects. The plugin I use just does this systematically for all indirect effects simultaneously, or sequentially, I guess, and produces a pretty table. So that's how you do it one by one. I'll show you now. Did you guys get the estimand and plugins and all that?
How did you label the A and B?
You don't have to. So in fact, if you're doing it with the plugin, don't label the A and B. I was just showing her the way without the plugin.
You put the regression weight as the A and B?
Yeah, isn't that weird?
That is really weird.
Yeah.
Okay, that's what's wrong.
What, Naveen?
So if I'm gonna do it manually with the A and B, I will need to go with every single mediating arrows, and like each time to name them A and B, and then calculate, and then A and B and calculate.
Yes, if you've theorized indirect effects through all, but otherwise just do the ones you theorized about.
I just did arrows on everything because there's no theory on what I'm studying.
Oh, just exploring it? Okay, yeah, then you'd have to do it for every path. Yeah.
Oh my God.
Which is why I created the plugin.
I know. But does it mean that if I look at your model, from playful to decision qual, there's it goes through useful. So does it have to be a line drawn from playful to decision call, or it doesn't matter?
Doesn't matter, but you could if you want.
Because if I delete that from my model, then I will gain more degrees of freedom.
That is correct. So as long as the model fit is good, then the model is good.
but I don't need to have this direct arrow to show mediation.
No, it is not required, as long as the model fit is good.
Neat. Thank you.
You're welcome. Okay, if you're doing the plugin, then the first thing you want to do is down at the very bottom, click on not estimating any estimand, and change that to select an estimand, and go select the specific indirect effects estimand that you downloaded. And then, up in the plugins, select specific indirect effect, or indirect effects. This one right here. And that will do some magic. It will warp your model a little bit, but it's worth it. Wait for it. Thinking. It's doing a lot of permutations is what it's doing. Because it's checking every possible indirect path. And it's going to produce them also for age and frequency. Oh man, and there's an arrow from, we have so many in here because the information acquisition leads to decision quality as well. So it's going to produce those as indirect paths. Oh, there are going to be so many. Let's see if it even computes. Thinking about it. Oh, did you also do bootstrapping on yours?
Oh, bootstrapping. That's
Sorry.
nice.
Yeah,
So
analysis properties, output tab. It created it. Or not output tab, analysis properties, bootstrap tab. And then perform the bootstrap, yes, check that. And then do bias corrected intervals, check that. Go to the bootstrap tab and then perform bootstrap and bias corrected intervals. Yeah.
My little plugin is showing just like a question mark in front of it.
Oh, did you unblock it?
It did.
Oh,
I'm going to try it again.
okay. If it runs successfully, it will produce an indirect path for every possible indirect path, which is fabulous. Plus, it produces a standardized estimate, which we didn't have before, and a significance indication on each one, which is really handy.
What
Plus,
does that mean?
the significance indication?
The standardized estimate.
Standardized estimate is the standardized indirect effect. It's the indirect effect, but standardized between plus and minus 1. Now, an indirect effect is always going to be kind of small because you're multiplying a decimal by a decimal to get a smaller decimal. So they're always going to be a little small, but not always non-significant. We can see we have several significant indirect paths here, which is pretty cool. Any success with those plugins? No?
That's okay.
All right, so I just can't get it to select my, what's the thing, the specific.
The estimand?
Estimand, yeah, so remind me where I select the
So yeah, if back in Amos, down at the bottom left, where it says not estimating any user-defined estimands,
Yes.
click on that.
Oh, that's where it was. Okay.
Yeah, and
it's
then
way down there.
select. Yeah.
Okay.
Then you select it. Then you run the plugin,
Okay.
assuming you're bootstrapping. And then it'll take a while to run because it is a lot of indirect paths.
Seriously.
Doing those manually would have been a pain in the rear. Anyway, but then you can report that yes, there is mediation from whatever to whatever. Let's look at this one down here. From usefulness to information acquisition to decision quality, there is an indirect effect. Here's the standardized indirect effect, and it is significant at 0.001 for the p-value. And that's specific indirect effects, mediation in Amos. This feature is not available by default. It wasn't available in Smart PLS by default either. So I asked the developers for it, and they said, okay, and they made it. I am following along, but not trying to do it myself yet. Okay. So in Smart PLS, check it out. It's super easy. None of these bunches of steps. In Smart PLS, you just go to Calculate and Bootstrapping. Run the bootstrap. Look at the output, and there is a specific indirect effects option. They added that. It's great. You can make a difference.
Wait a minute, back up.
Yeah, you don't have that one?
Run it again for me.
Yeah, so back here, I went to Calculate and Bootstrapping.
Okay.
And when it ran, it produced,
Check anything else.
I didn't, no, let's see, Bootstrapping. I used 500 draws or subsamples. I should use path weighting. And that's it. Those are the only changes. So let me run this.
Set 5,000 samples.
You set 5,000. Oh, that's more appropriate. It's more appropriate to have 5,000 than 500. Yeah, it'll take a minute or so. But when you do it, you'll be able to see down at the bottom, there's a specific indirect effects option. And you just click on that, and it shows you every possible specific indirect effect. Isn't that crazy? It's awesome. And it gives you the p-value for them. If it's red, no good. If it's green, it's good. Very nice, very handy. You can open this up and see what they are. It even gives you serial effects. Look at this, serial mediation. From anxiety to useful to info to decision quality, all the way through. Isn't that awesome? That's pretty
So you don't, okay, can you go back to the diagramming tab?
Yeah.
So you don't have to click then on your particular endogenous variable and add the moderating effect.
No, we're doing mediation right now.
Oh, we're mediating.
Yeah,
Okay.
we'll do moderation in just a sec.
I'm sorry,
Yeah,
conflating the two.
you're good. So mediation, indirect effects. Is it still bootstrapping?
No, it's done.
Oh, okay. Good. So that's it for Smart PLS. I mean, it's that easy. You just run the bootstrap and it gives you the output. Is there effect size on indirect effect? Let's check if there's an effect size for indirect effect. We go here, we look at, let's see, effect size is actually in the other, so I bet it's not. Effect size is when I go like this, PLS algorithm. I'm betting it won't create an effect size for indirect effects, but we can check. F square is the effect size, and it does not produce it for indirect effects. No. I haven't talked about effect size. Effect size is how large is the effect, regardless of p-value, regardless of the beta coefficient, how big is the effect that we're having on this dependent variable. And you want an effect bigger than 0.015, but ideally more than 0.35. That'd be great. And you see here we have some decent effects from playfulness, from decision quality to information acquisition. That's a big effect. It's called a strong effect or effect size. And that's reported quite often when the p-value is irrelevant, like with a really high sample size. So that's in the F squared table, that's produced when you just run the regular PLS algorithm. We should talk briefly also, as long as we're in Smart PLS, running on a path model, let's talk about collinearity, multicollinearity at the inner model, the structural model. There's a link for that. And you just need to look at the inner VIFs, and this tells you if any of your predictors are redundant with each other, if they're inflating the variance explained in a dependent variable by explaining the same variance. And the answer is no. You want these values under 3.3, and all of them are less than that. If they were more than that, then you'd say, oh, that factor is maybe somewhat redundant with this other factor. And you might try to distinguish those again in an EFA.
3.3 in your inner.
Yeah, in the inner. Yeah, in the inner.
5 and.
In the outer, yeah, 5 or 10. Yeah. 10 is like super loose, but 5 is appropriate.
Yeah, all of my outer ones were below 5, and the inner are all
Below 3?
well below 3.
Good.
Barely over 1.
Then we're good. It's pretty uncommon to have VIF issues unless you designed your survey really poorly.
Now, common method bias.
Method bias in Smart PLS is tricky because method bias is based on the covariance matrix, and PLS is not based on the covariance matrix. And so to do method bias in PLS, the way you would do it is with a VIF approach. And any VIFs in your inner VIFs above 3.3 would constitute a possibility of method bias.
That.
Okay.
On the site for,
Yeah, it's for NEDCOC
yeah,
2015.
2015. That's
Yeah.
what I cited.
Yeah. PLS is so fast and easy. I wish we just use that.
It
Okay.
must be growing pretty fast by the number of citations for all of the different things.
It is, and I hope it continues to grow. So that was specific indirect effects in Smart PLS. Now it's time for moderation. Interactions. Interaction, let me see. Yes?
Can I ask a few questions?
Of course, of course.
So, when I tried to do the mediation in Amos with 2 mediators, some people advised me to use Monte Carlo calculator.
Uh-huh.
Can you say a few words about this method?
So,
Because I'm now like so confused with the plugins and what you're suggesting.
yeah, there is in the estimation. Is it here? I've never used Monte Carlo in Amos. Where is it?
No, it's not in Amos. It different. You have to like source it out from outside.
Yeah.
Because Amos doesn't have it.
So yeah, because Amos doesn't separate out those effects, you have to do something else. I got around it by writing a little program that would calculate it for me. You can see here, I can show you. I just wrote code to augment Amos, essentially doing what other programs do, but in Amos. You could also take it out to do Monte Carlo tests, but man, that would be complicated. I tested this estimand against M+, which is considered most rigorous, and it is identical down to like the 1,000th decimal. So that would be the easier approach. Sorry, what?
This is how you created the plugin for this one?
Yeah, the specific indirect effects, I created it by mimicking the approach taken in other softwares that don't aggregate indirect effects.
And would it work also with dyadic data sets?
I'm not sure. I've never messed with dyadic data sets.
I know nobody wants to mess with that.
Yeah.
Psychology.
So messy. I want to kill myself.
Oh, I'm so sorry.
So and the 3 stars that we just saw in the table that you showed at the end.
Yes.
Does it
over here.
say that it's 0.001?
Yeah, the p-value is less than 0.001. Here's the significance indicator right here, indications.
Oh, okay. So it will give it to me.
Yeah.
And when I report that in an article, should I put the lower bound and then the upper bound and then the estimates, or without the estimate?
I would put the full table. More information is usually better to a certain point. The minimum required would just be this last column, standardized estimates with the p-value indication. Yeah, I'd like the first column and the last column. That'd be the minimum I'd report.
You wouldn't put the lower and upper?
No, what I was saying is I'd report all of it, but if I wanted to keep it minimalist, I'd just report the path and the standardized estimate with the significance indicator. But I would report all of it. I'd report the lower, the upper, the p-value, the unstandardized. I'd report all of it.
And would you also report the direct effect?
You could if it was being estimated, but not in all cases are these being estimated.
So for the direct effects, you would do a bootstrapping and then...
For direct effect, you don't even need to bootstrap. If it's there, it just has a value. You can see like 0.31 here. That's the direct effect for this.
Just to report the estimates?
Yeah, you could do that if you want for the direct effect with the p-value.
because I want to prove the mediation, so they usually want to see that there's no direct effect, and the
Right.
only,
The approach to mediation has evolved quite a bit over the past 20 years. And different approaches have been advocated and are still advocated. The general consensus currently is that if you have a model that fits, meaning you've modeled the effects appropriately, and you have an indirect effect that is significant, then you do have mediation. Whether there's a direct effect included or not is irrelevant in that, if there is model fit.
so we don't report full or partial mediation anymore?
Some journals still prefer it if you report full or partial. And in this case, full would be if there doesn't need to be a direct effect to achieve good model fit, or if the direct effect is not significant. Whereas partial would be that there must be a direct effect included and that direct effect is significant.
Thank you so much.
You're welcome. Okay. So we were getting, sorry?
So we calculate these indirect effects. We find the ones that are significant and we report it. We don't have any theory for that. See, again,
No. So the way I approach this is I theorize that the effect from playfulness to information acquisition is mediated by usefulness or whatever. I write up my hypothesis and my support for that hypothesis, and then I go test that indirect effect.
Yeah, but when I run the plugin, it tests all.
It just tests, yeah, the plugin tests all of them.
But what if I see one that's a surprise?
So okay. Yeah, let's say we didn't theorize about this one right here that is significant. Then what do I do? Well, I could report it in a post hoc. Be like, I didn't theorize about this, but look what I found. Still adding to knowledge, right? Adding to science. But I would keep it as a post hoc or post analysis. I guess post hoc is a reserved word phrase, but it is like an afterwards analysis. Yeah. There you go. Recommendations for future research. Okay. Let's run some moderation in Amos and then Smart PLS.
One other question in the PLS output and with mediation is on the output there, is that the difference between the means or the difference that creates the mean in that first line?
This first line here?
Yeah, or the second line.
There's the original
sample.
And then sample mean. Are you asking me what's the difference between those?
Yeah, describe what that particular output.
So the original sample is the regression weight on the first estimation, the first run. The sample mean is that regression weight averaged across all 5,000 runs. So I always report the sample mean, not the original. Yeah. I didn't actually explain what bootstrapping is. Does anyone want to know or care? Yeah. So bootstrapping is where with your entire sample, instead of using row number 17 or whatever, you replace row number 17's value with an average value. And you do it for row number 27 and 37 and 47 or whatever your random seed is. And you do it 500 times, replacing with the mean 500 times. And then you average what the effects are so that any outliers or any oddities or people out in the distribution, their effects are minimized. You reduce error. It also allows you to produce a confidence interval that you couldn't produce otherwise.
And the standard deviation in that output is equivalent to the standard error in the bootstrap.
Right here, the standard deviation. This is, that would be the standard deviation on the mean value.
Okay.
Yeah, so there will be a distribution of means, or sorry, a distribution of regression weights calculated. And then the mean, of course, is the mean of that distribution. And in this case, the standard deviation is for that distribution of regression weights. All 5,000 of them, however many you calculated. It's cool stuff. And the t-stat is just the critical value. 1.96 or above typically is significant. Okay. So let's do some moderation. To do interactions in Amos is unfortunately not terribly easy. It requires some work in SPSS first. So what you have to do is go back to SPSS let's see, let me go find my, undo that. Here are all my variables. There we go. Actually, it doesn't really matter, but okay, here, so in SPSS, what you have to do is you have to prep your variables by standardizing them, at least the ones you're going to use for the interactions. An interaction is just multiplying one variable by another variable and seeing what the effect of its product is on another variable. So using the _C data set, the one we imputed from Amos, what we'd have to do is go to, who's following along step by step? Are you, okay, so do you have this data set? Okay. Analyze, descriptives, and then you're going to go to the very bottom of this data set and bring in the ones we're going to use in moderation. Our model says we're moderating the effect from playfulness to usefulness and playfulness to information, or no, and anxiety to usefulness by experience. So we need to standardize playfulness, anxiety, and experience. So we'll get those in here. Playfulness, anxiety, and experience. Throw those in. And then check the box for save standardized values as variables. That checkbox right there. What that's going to do is it's just going to create standardized variables for those three. Hit OK. It creates 3 new variables for those 3. They're at the bottom here: Z experience, Z play, Z anxiety. And then we have to multiply them together, 2 by 2. So we go to data, transform, compute variable. Transform, compute, and then we're going to have 2 new variables. One will be exp times play, no spaces. I used underscores in this case. And then it's literally going to be just this down here, exp, z-exp, times, and I just double click it, playfulness, z playfulness. So it's just that times that, and then hit OK. And then I'm going to do the exact same thing, compute variable, but instead of exp times play, I'll do exp times anxiety, ANX, and change out playfulness for anxiety. Like that. And then, yep, calculate that. We now have 2 new interaction terms in our data set. You'll see at the bottom here, exp times play, exp times anxiety. We now want to save this data set and go back to Amos, relink the data set using data files, double click that data file, and go find it again, and just bring it in. It's the same data set, we just have to refresh that connection. Make sure bringing in the _C and make sure you have saved it in SPSS first. If you haven't saved it in SPSS, this won't work. And then hit OK. And now we have, if we go to our white stacky thing, we have at the very bottom those 2 new variables. Before we can bring them in, we got to down arrow this thing so nothing's showing. Oh, I have all those named. Bother. Is there an easy way around this? It doesn't matter if they're named. It'll still calculate everything I want. So it's fine. Okay. So white stacky thing, bottom of it, bring in exp times play, exp times anxiety. You just drag them in. If they don't drag in, make sure you hit the down arrow first so no estimates are showing. Otherwise, it won't let you bring stuff in. Use the fire truck to put them wherever you want. I'll put one down, one up. I better switch them around. Let's see. There we go. And then draw the lines from those to computer comprehensive use, because that's what we theorized. Or no, was it to usefulness? Is that what we theorized? It was to usefulness. Whoops. So from EXP or from these interactions to usefulness. And then, unfortunately, we also need to covary those with all of the exogenous variables. There's a shortcut to that. If you use your single finger, pointer finger thingy, you can select all the exogenous variables and then use the draw covariances plugin, which is already in there. You don't have to go download it. You go to plugins, draw covariances, and then it automatically draws all those covariances.
Including ones that you already have?
It'll just replace those.
Or replace them.
Yeah. You're not gonna have like a double up or something. It's a messy model, yep, but it's ready. Okay, let me think through this. Yep, save. I'm gonna save this as interaction. You can just save if you want. I'm just gonna save this separately. Interaction, and I'm gonna run it. Oh, it's estimating specific indirect effects, whoops. You might want to estimate specific indirect effects. It's going to throw an error. Dang, it's thinking. Oops. I can't exit out of that. All right, give it a sec, sorry. It's estimating all these indirect effects. So what we should have done is gone back and clicked on estimating estimand and not estimated an estimand. There should be like a cancel button or something. Maybe if I just hit next, can I do that? Close program. Watch me break Amos. There we go. All right, let me open it back up. Interaction. Here we go. Okay. And let me get rid of this estimating specific indirect effects. Do not estimate. There we go. And I'm going to get rid of bootstrapping. I don't need a bootstrap. And now save and run.
You get to bootstrap.
Oh, click on the analysis properties, colored abacus, and then go to the bootstrap tab, and then uncheck those two boxes. So we ran it. Go ahead and run it. And when you run it, same thing as before. You can see the effects it has on stuff. For me, the interaction terms had pretty nominal effects, negative 0.04, and let's see, from this one to this one, negative 0.04. Both were negative 0.04, which is pretty minor. If we go look at the output, we can see if there were significant effects, estimates, scalars, regression weights. And we can see from the interaction effects, these two, oh, not calculated? I don't know. Maybe it didn't calculate. Oh, here they are, sorry. Here we are, okay. These two ended up at 0.065 significance. Very similar. Not significant at the 0.05 level, but significant at the 90% confidence level. And what we can do with that is you can use the interaction plotter. Do either of you have the stats package, the Excel stats tools thingy? No? So go here. Go to the stat wiki. Stat wiki. This thing. I made this as a little kid. So I called it Collab Creations because I didn't know what I was doing. Anyway, so it's statwiki.collabcreations.com. And on the main page, if you just scroll down a little bit, there is a big Excel icon. You want to download that Excel tool, and not by clicking on the icon, but by clicking at the link that says Stats Tools Package. this has a tool for plotting our interactions and interpreting them. So if you, that's on the statwiki.colabcreations.com. So if you download that, enable the macros in it, when you open it, stats tools package. There are a bunch of tabs down here, and one is called two-way interaction. You want to click on the two-way interaction sheet. And in here, you can put a bunch of stuff. We had, as our independent variable, we had play. As our moderator, we had experience. And as our dependent variable, we had useful. If I can spell that. Useful. There we go. The effect of play on useful using unstandardized regression weights. Play on useful, if we go out here, it was 0.215. So 0.215. From experience to playful, or from experience to useful, excuse me. Oh, I didn't include experience. Whoops. Haha, we need to include one more variable. My bad. Back to Amos. I knew I was forgetting something. Throw in experience. Sorry about that. As one more variable. Predicting usefulness. Ooh, I need to change that setting.
That's how you make them smaller.
Yeah, there's a little, there's a resizing icon.
Right.
You can also do this one. This is a fun one. Plugins resize observed variables, and it makes them all the same size. But it sizes them to the largest one. So don't do that if you have like a really big one. Anyway, draw that to useful. And then again, you have to covary it with all the exogenous variables.
We have to draw it also to confuse, right?
Only if we're theorizing that effect, and I don't think we are. We are not. We're not theorizing that moderation effect. So I'm going to highlight each of these exogenous variables. Man, I can't wait to do this in Smart PLS. It's so fast, so easy. I'm going to draw covariances. There we go. Deselect everything. Save it. Rerun it. Then go look at the output and put in those values. Estimates, here they are. And we said from play to useful 217, so actually went up a little bit. 0.217 from experience to useful, which would be down here. Where'd you go? Here's experience to useful is nothing, negative 0.006. Negative 0.006. And the interactions effect, that would be from experience times play to useful. That's negative 0.036 for me. Got that line right there. Negative 0.036. Whew. That is our interaction. There is a slightly different slope for those for the high and low playfulness, and high and low experience, but not a huge difference. The interpretation would be that experience dampens the positive relationship between play and useful. So there's a positive relationship between play and useful, and when you have high experience, it's a slightly lower slope. That's what that means. So you could report this table. You'd want to format it, make it look prettier, move those formulas, and You get the exact formula for the slopes. That's kind of nice. Anyway, there it is. And you can do the same with the other interaction. And that's how you do. Yeah, hello?
Yes. Do you look at the model fit after you added the interactions? Of the
Oh,
model?
yeah, you should. Thank you for reminding me. Anytime we test a hypothesis and the model changes, we need to look at model fit. So yes, thank you for the reminder. Let's look at model fit. And the model fit is still good, thank goodness. Just looking at the CFI. I could look at everything else, I guess, do a full model fit. But yeah, we're still good. See the RMSE AP close. But yeah, that's critical. Thank you for the reminder, Naveen. Anytime you test a hypothesis and the model has changed, you've added or taken away a variable or a relationship, you must assess model fit before you test the hypothesis. Otherwise, you can't have confidence in your hypothesis test. Good catch.
Let's say it's ruined it for you. So would you like eliminate some arrows just to get a better model fit?
Well, the model fit's great. But if it was terrible, yeah, we'd maybe go look at the modification indices and see why it was terrible. But we don't need to optimize fit. We don't need to make it better. Okay. So that's the painful model fit or painful interaction process in AMOS. Now, to do it in Smart PLS, where'd you go? I know you're here somewhere. There you go. Smart PLS. Back to the model. Here's the super complicated way to do it in Smart PLS. You click on latent variable. Stick another one in there. I'll stick it down here by usefulness. Name this what it's supposed to be by select, rename. Call this experience. And then we draw an arrow from this to usefulness. We give it its experience, which is down here. Let's see, in the indicator, oops. Here's experience down here. We gotta drag it out to the experience circle. And then here's all you have to do with the select icon. All you have to do to create an interaction in Smart PLS is you right-click the dependent variable you're interacting on, say add moderating effect. What is the moderator? Experience. What is the independent variable? Play. What approach do you want to take? Two-stage. Trust me on that one. What that does is it creates factor scores and then multiplies the factor scores instead of multiplying every possible indicator. So that's the better approach according to the book.
Parent Colleagues 2017.
Yeah, the PLS primer, that one. It says use the two-stage approach. The old approach used to use the product indicator approach where you standardize every indicator and then multiply every indicator and then you end up with like 50 indicators. But two-stage is considered better. Okay. And then we'll just use automatic weighting scheme, standardized approach rather than mean-centered. Hit OK. So it's just the defaults on those. And it creates, here's your interaction term right here. And if I were to open this up, you can see what's inside of it. It's just playfulness times experience. And that's the playful factor score that it just generated on the fly for us. And it created for us. And then all we have to do is run our PLS algorithm. Hit run. And we can look at the interaction. The simple slope analysis down here, I'll show you. Down at the very bottom of your output, there's a simple slope analysis. And that will generate this graph, which is terribly skewed, but you can copy it out into another program. So if you see a copy to clipboard, the chart, this button up here. If you click on that button, you can then change some settings to the size of the chart you want. Hit OK, and then go to Word and just paste it in there. So paste it down here somewhere. Let's see, Control New, paste, and here is your simple slope analysis, where you have low experience, medium experience, high experience. blue, red, and green. So in terms of high experience, the effect is slower, what do you call it? It's dampened, just like we found in Amos. For low experience, the effect is stronger. So their interpretation again is that experience dampens the positive relationship between play and usefulness. But that was way easier. That's all you have to do. We're done with that. You may ask, we didn't check model fit for this one. It's because PLS is, again, not covariance-based, and model fit is covariance-based measure. The Chisquare statistic is the model fit statistic and is computed using the covariance matrix. PLS doesn't use the covariance matrix, so there is not a model fit measure, although they included some just to satisfy some people. If you were to go look at the output, there is a model fit section down here at the bottom. But they recommend against it, which is funny. In their book, they're like, we don't recommend this very highly because it's not relevant in PLS. And you look at the SRMR, and you want the SRMR less than 0.08. And we're good. We have less than 0.08. We have a good model. It means we're not missing any critical paths.
They say with the NFI of a 0.9, but I mean, how firm is that?
NFI, from what I read and understood from what they wrote, they don't recommend any of these measures except maybe the SRMR. There's another article that's hopefully going to get published soon. I reviewed it a year ago, and they argue for how to include the AIC and BIC and the DG in PLS, and they found the AIC to be the most accurate. So we'll see if they can include it.
Square peg, round hole.
Huh?
Square peg, round hole.
It is. It's a square peg, round hole problem. We're trying to fit a covariance-based metric into a non-covariance-based system. Yeah. Okay. Well, that's interaction in Smart PLS. Pretty straightforward. Oh, we are almost done. Oh, we have 15 minutes. Yikes. Yes?
Maybe this isn't important, but going back to those moderating terms, the significance level.
Oh, yeah, we can look at the p-values on those.
It's a little bit tricky in the way it's reported.
Yeah, so what you have to do to get the p-value of those interactions is go to calculate and do a bootstrap. I'm not going to do a 5,000, I'm going to do 500 for simplicity's sake for a moment. Run the bootstrap. Look at the output, and it creates an output for, it creates one for that moderating effect. You can see right here. Moderating effect to useful, p-value not significant. But the literature right now says largely to ignore the p-value on an interaction term and to look instead at the slope analysis. The even better approach is to use something that could calculate confidence intervals over a range of estimated values and then say for what estimated values is the interaction relevant. But Smart PLS doesn't enable that. M+ does. So that's one advantage of M+. Okay. The last thing is multi-group analysis, where you compare this model across two groups. I want to go back to my initial path model that's not so messy. Do I have it? Please tell me I have it. Where'd it go? Let's go to open. No, I don't want to save that. Path initial, here we go. That's better. Okay, so we have this model in AMS. We want to determine whether the effects are different across gender. We could leave the interactions in there, but then we'd be doing moderated moderation, which is really complicated, and I'd rather not do that. So the way you do multiple groups in AMOS, we looked at before with invariance. Double click group number 1 up top there where it says group number 1. You're just going to double click that and then change it to male and then hit new and change group number 2 to female, just like we did before with invariance. So now we have 2 groups. And hit close. And then we have to assign the data, just like before. So you have to link the data to each group, select data files, go find that same data set, and then give a grouping value or variable and grouping value to each group, male and female, just like before. Grouping variable is gender. Grouping value for males is 1. And grouping variable gender. Grouping value 2. So you end up with something like this. Okay. Then you hit OK. And we now have the model set up for male and female. We could just run this and see that the paths do change. Hit the up arrow, and you see when you toggle between male and female, those paths do change. Let me zoom in. There we go. But we can also calculate the difference between those paths. There are multiple ways to do this. Amos doesn't provide a good, easy way. Although, you know what we could do, actually, they do provide this way. Just like we did with invariance, we can do a multi-group analysis right here. And you hit OK. That's with that multi-grouping tool down there. And then just use the defaults here, because we're only interested in the structural weight differences. So you hit OK. And then you run the model. And what we want to do is go to the output and look at those model comparisons and look specifically at the structural weights. And it says p-value not significant. That means in this case, and we want it to be significant in this case, whereas in the measurement model we want it to be not significant. Unfortunately, we got the opposite both times. This says that when we look at the structural weights between variables and across groups, there is no difference between men and women in terms of the relationships in this model. And that's that. If we wanted to look at a specific one, what we could do is we could go release that constraint. So let's pretend that we were significant. We could go look at, let's say, playfulness to usefulness. How about that one? We go to the structural weights model over here. Structural weights. And we want to release that one. That one was B6. So we go find B6 right here. And we get rid of that one line, B6_1_2. Just delete that line. So it is no longer constrained across groups. And if we now have a significant p-value, then we know, well, that path is a moderating path, or is a moderated path. And it is different between men and women. So let's find out. Let's run it. My guess is we won't have significant difference, but we can check anyway. Model comparisons. And still the p-value is 882. So nope, that path is the same for men and for women. And that's how you test multi-group moderation in Amos. It's pretty easy, actually. In Smart PLS, the way you test it is like this. Back in your data set, so back here, let's see. Are you also doing multi-group moderation?
Yeah, I have done them.
Oh, you've done them? Okay. So do you want me to show? I'll show it for the sake of the video, I guess. And there are people watching online who want to see it. But back in your data set, you can define a multi-grouping variable, a grouping variable. Let's see. That was generate, add data group right here. So you double click on your data set, add data group. We're going to call this gender. And let's see, we're going to click on the first box, find gender. Where'd you go, gender? Here you are. Gender is equal to 1, add term, and gender, again, is equal to 2 is a group. So that's male and female. And then you hit OK. So now we have 2 groups. Gender says 0 records. That wasn't supposed to happen. All right, let's do it this way instead. Let's delete this group if that didn't work for you, and generate data groups instead. We'll just generate it right from gender. Group column, gender. Group column 1, group. And that's all I want, gender right there. Total 2, hit OK. There we go. Has gender 1, gender 2. Male and female, and those are the same size, sample sizes we saw in Amos, so we know we've done it right. And then what you can do is in your model, to do a multi-group analysis, go to calculate, multi-group analysis. And it has tools right for it. So you run this, you select your groups. Wow, that is terrible aesthetics there. Oh my goodness, that's hard to see. Group A is going to be gender 1, group B is going to be gender 2. And you hit start. It runs it for both groups. Lots of running. Output, idle, timer expired. Oh, that's for my Citrix server. That's unrelated. Okay, you can look at the MGA, which is right here, this tab. So MGA, and here is, for this path, for this path, here's the difference, and here's the p-value. Sorry, that's really enormous. I should have not. Let me just go to this. It doesn't reset it. I'll go here. There we go. Okay, so it says for this path, here's the difference in the estimate, here's the p-value. And the green ones mean, well, green, I'm not sure why that green one is green. That should not be green. It should only be green if it's less than 0.05. I'm not sure what's going on there. So it says, just like in Amos, there are no differences between men and women when it comes to this model. And it tests all paths for us already, which is kind of nice. We don't have to like go unconstrain and reconstrain and all that. So it's super easy, Smart PLS. And that's moderation. Did we just finish? Let me go check the slides. Not those slides. Let me check this one. We did, oh, that's different stuff. And we'll go here, CFA. I didn't even open the causal analysis slides. Haha. Let me go open them. I think we just finished everything. Cluster analysis, causal models. We talked about that. We talked about that. We talked about that and that. We didn't really talk about what is a mediator, what is a moderator. Mediator is reason for the effect the IV has on the DV. Moderator is something that changes that effect, changes that relationship. So a mediator, a mediator would be something like these. Autonomy leads to job satisfaction because autonomy leads to a feeling of empowerment, which leads to job satisfaction. Or because autonomy leads to a feeling of task ownership, which leads to job satisfaction. Whereas a moderator would be something like these. Autonomy leads to job satisfaction, but it depends on training. Autonomy doesn't lead to training, but the effect autonomy has on job satisfaction depends on training. The more you've been trained, the more autonomy helps job satisfaction. The less you've been trained, the less that effect is good. I don't know about gender, but it could change that effect. Years of the job could change that effect. So they all change the effect. They aren't a result of autonomy. They change the effect autonomy has on job satisfaction. So that's a moderator. We talked about that. We talked about that. We did that. We did that. We talked about that. We did that. We did that. We did that. We talked about controls. So controls are the things you just want to control for, but don't want to theorize about. And you just treat them like independent variables. And in your report, in your write-up, you just put them at the bottom of your table. You still report everything as you would for any other variable, but they're just at the bottom of your table. You should also explain why you included them. I reviewed a paper a month ago. It was testing for the intentions to adopt virtual reality technologies, and they controlled for, wait for it, political persuasion, sexual orientation, age, income. Like, what did those have to do with anything in this theory? So I wrote them back. I was like, why did you control for those? And they took them out. I don't know what they were thinking. Like, who asked about sexual orientation on a survey about technology? Anyway, okay. We talked about that. Talked about that. Controls, it's really important to include controls so that we can trust the effects we observe. It's like my example of firm performance. If you're not controlling for firm size, I don't care what you say predicts firm performance because it's firm size. If you're controlling for firm size, then anything that does significantly predict firm performance, that's something to talk about because it's something other than firm size. These guys did a test on TV time and obesity, and they controlled for everything under the sun to show that even when controlling for all this other stuff, the more time you spend watching TV, the more obese you are. So that was a cool study, but it was only valid because they controlled for all this stuff. Here's some recommendations that are pretty self-evident. We did that exercise. We did these. Oh, wow. So the last thing is if it would help for whatever reason, if your institution would like you to have a certificate of completion of SEM Boot Camp, I will send you a certificate of completion. You just have to email me and ask for it. Some institutions care, some people care, most faculty don't care because what are you trying to prove, right? So if you want a certificate of completion of the boot camp, email me. I will send it to you. It doesn't look amazing because I designed it, but it'll be legit. It'll have my signature and all that. And that's it. Oh, that's the first time I've gotten through it in 2 days. So you guys don't have to come tomorrow. But anyone who wants to do M+, come tomorrow. Yeah.
I like the certificate because military teaches it.
Okay, yeah. So if you email me, it will be a thing. If you don't email me, it's gone. Yeah, my brain is not currently here. Okay, that applies to remote folks as well. If you guys want a certificate, email me. Don't just send me a chat message here. Go ahead and email me directly. I'll email everybody just so they remember. I'll email you to ask if you want it. But go ahead and feel free to email me if you want a certificate. Any other questions?
Yes. Can you say, please, what are we going to do tomorrow?
Yes, tomorrow I am going to focus the entire time on M+, which I know wasn't part of the schedule, but we finished the entire schedule in 2 days, which was awesome, and has never happened before. So I'll focus the entire morning on M+, and then in the afternoon, if you'd like me to sit with you virtually, I'm happy to sit with you, look at your data, answer your questions. I'm happy to do one-on-one time tomorrow if anybody wants.
Yes.
Okay.
I want. Please include me.
Okay, so then
because
go ahead.
I have tried in the lunch break to do everything that you have taught,
Okay.
and I have succeeded in 0.
Oh no, okay.
Yes, everything went very, very wrong. So I would sit on it tonight.
Okay.
When my baby goes to bed, and then in the morning when you will be teaching M+, I will be continuing working on it, so I will be more ready for the one-on-one.
Okay, and then
if that's okay.
Yes, that sounds great. And then is it okay if I just email you when I'm ready to do it?
Sure, of course.
Okay, let's do that. I'll email you when I'm ready. Should I record the M+ session or not bother? Nope. Yeah, I won't bother. Okay. I have videos on M+ that anyone can watch. All right, so then Naveen, I will email you when I'm ready to visit with you. Is there anyone else remotely who would like to schedule some time with me tomorrow? There's a chat. No? All right. Yes, please. Oh, record M+. Okay, I'll record M+. And Carl would like some one-on-one time. Okay. So then...
Maybe we can all see the one-on-ones, so maybe we can learn from each other's mistakes.
Yeah, sure, we can do this. How about tomorrow? All right, we'll do this tomorrow. Tomorrow morning, I'm going to hold the session like usual. Whoever wants to show up can. You're welcome remotely to just like log in, and then I'll just tell you when I'm done and ready. If that works.
Sure.
Okay. Okay, and then we might even just finish before lunch. Who knows? Or if there's, or we'll just go into lunch because I know you guys are remote. Lunch doesn't matter. Okay.
It does. We also need to eat.
You can eat while you're watching. I can't eat while I'm talking. Okay.
Of course.
Recording here, and I'll post these and email me if you want a certificate, and I'll see you guys tomorrow if you're coming tomorrow.